Look at an example problem where we will find one of the ways to make use of the equation that we derived when we were looking at diffusion in a path, a change in path. Previously, we want to use that to calculate GAB. So let's look at this example problem. We have got a vertical glass tube 3 millimeters in diameter, which is filled with liquid toluene to a depth of 20 millimeters from the top. Open end. After 275 hours at 39.4 degrees and a total pressure of 760 millimeters mercury, the level is dropped to 80 millimeters from the top. Calculate the value of diffusivity. So data given there, pressure 7.64 kilonewtons, our density of liquid toluene 850 kgs, our molecular weight of toluene, then 760 millimeters of mercury, which is equals to 101. So you look at this for illustration purposes. For illustration purposes. So this is our glass field, and we are there, and this is 20. This is 20. This is 20 millimeters, and our T there is equal to 0. So we are saying that we will drop to somewhere there where we have is now 80 millimeters from the top. So we've moved from there to there. So we want to use this to calculate our diffusivity. So let's look at the data that we are given there. Right, so we are given our gas constant, which is R, is 8314. Of course, this depends on the units that you want to apply in the equation. Then we have our T3, 39.4 degrees, and our total pressure is 760 millimeter mercury. Then our pressure PA1 is 7.64. Then our pressure PA2 is equals to zero point 0 kilonewton per square meter. Then DAB is not known. ZT equals to 20 millimeters, and ZTF, which is final, 80 millimeters, and our density 850 and molecular mass there is 92. Right. So you can either make use of the equation with partial pressures or mole fraction. For this problem, let's make use of equation with mole fraction. So that means we would need to first convert our data that is in partial pressures to mole fraction. So let's begin by converting our determining the total concentration there, making use of the gas of the gas law there is indicated. So our PAE there is given, R we have, T we have. So we can input that and get this equation. All that matters is consistency in our units. Then moving on, our mole fraction there is given as YA is equals to PA over P. Remember remember that um, this value is given as 7.4 kilonewton per square meter. Then YA2 there is given also. YA2 is calculated using PA2 over P, and PA2 is 0, so YA2 becomes 0 also. So YB2 is equal to 1 minus YA2 equal to 0. We have calculated our YA2 there. The way YA2 there has been calculated. YA2 there has been calculated as using that. So we want to substitute for that value there. Then YB2, we make use of YA1. So we are substituting this value there to get this value. Therefore, we can now then calculate our log mean, since we have already calculated those values. So the values that we are making use of is for our YB. We make use of that, and our YB1, we make use of that value. Then we calculate to get to a value of 0.96 there. Right. So then moving forward, therefore now calculating GAB there. So just to avoid any doubt, this equation is the one we obtained. We obtained uh, when we were calculating. So this is the value we obtained there. We have simply made GAB the subject of the formula. So this is where we are. And every other data there in this equation we've managed is either given in the question or we've made calculations, and we are, after substituting, checking consistency of units, we get our 9.15877 times 10 to the power minus 6 meter squared per second. Thank you.